Good morning, everyone, and welcome to another episode of Mrs. Ross Does Math. Today's lesson is for Math 7, the topic, Lesson 13, Probability. This is our second lesson in the last unit we will be completing for the year, and let's get things started. So here we go. Once again, our topic for today is Lesson 13, Probability. Our essential question, how can I find and interpret experimental and theoretical probabilities? So the two types of probabilities we will be learning about today are experimental and theoretical. So I'm going to underline those two. And not only are we going to be finding them, but we are also going to be interpreting them. Okay? Now, first of all, I want to go over what is the definition of probability. Probability is the measure of how likely it is an event will occur. Well, didn't mean for that to be there. So, when we talk about probability, we're thinking of if I roll a dice 10 times, what's the likelihood that I would say get an odd number, a 1, a 3, or a 5? Well, since a dice has 6 sides to it, the numbers 1 through 6, and odds, the numbers 1, 3, and 5 show up either 1, 3, or 5, 3 different times, there's 3 different possible numbers, my likelihood would be that if I roll it 10 times, I'd get 3 over 10. And when we talk about probability, we talk about it being as a symbol as well. You'll see this symbol a lot on your assignment today, and that is P and then parentheses. So that means the probability of. So if this said the probability of heads on a coin, well, the probability of heads would be 1 out of 2, because there's 2 sides to a coin, heads or tails. The probability I'd get heads is 1, because there's 1 heads out of 2 sides. So my probability would be 1 out of 2. We're going to continue with that in just a moment. Now, another piece of probability that we have is outcomes. Now, the outcomes are the possible results you can have from a probability experiment. So today, we are going to have both experimental outcomes and theoretical outcomes. Okay. Now, like I said above, when we talk about probability, there's 2 different types. The first one is theoretical probability. Theoretical probability is the ratio of favorable outcomes to possible outcomes. Apparently, I had a hard time writing notes that day. So once again, theoretical probability, the ratio of favorable outcomes, so favorable outcomes to possible outcomes. And again, the other word that we have here is ratio. So another way of looking at this is the probability of our event is equals to the number of favorable over the number possible. Okay, because once again, a ratio is also a fraction. So here I have a fraction of my favorable outcomes on top, my possible outcomes down below. So we've got an example. And our example is this. Find the probability of 1 or 2, that's what, again, probability of 1 or 2, when rolling a dice. So, let's think about this. I want a 1 or a 2 on a dice. Now, when I take a look at this, I'm taking a look at my favorable outcomes, which are going to be the 1 or the 2, over my possible outcomes, which on a dice could be 1, 2, 3, 4, 5, or 6. Now here, there's 6 options that I could have. 1, 2, 3, 4, 5, or 6. I only want a 1 or a 2, so I only have 2 favorable options out of 6 possible. So I'm going to get a ratio of 2 to 6. Now, anytime we talk about probability, ratios, fractions, we always want these in simplest form. So my probability of getting a 1 or a 2 when rolling a dice is going to be 1/3. This is our theoretical probability. So this is if I wanted to roll a dice and I only wanted a 1 or a 2, what is the chance that I get a 1 or a 2? And that would be 1/3. Now, that's theoretical. Experimental is something that you guys use a lot more often, especially in science. When we talk about experimental probability, we talk about a probability that's based on what does happen after an experiment. So once again, experimental probability is based on what has actually happened. Okay? So just like our theoretical probability, we have a ratio that it can be set up towards. Now, for experimental probability, that is, the probability of the event is equals to the number of times the event actually occurs and the number of trials in the experiment. So I could say that I am hypothesizing, this would be theoretical, that I would get heads 20 times when I flipped it 40 times. My experimental probability would be me actually doing that experiment and figuring out how many times I actually got heads out of 40. Because again, that's the amount of times it actually occurs out of the number of times I actually attempted it. So we have another example here, and that is this. Kyle flips a quarter 32 times and got heads 14 times. What was his probability of getting heads again? So, Kyle flipped the quarter 32 times. That is the number of times in our experiment. Okay? So, we're talking about the probability of getting heads once again. He flipped the coin 32 times. That was the number of attempts, and he actually got heads 14 times. 14 times. Okay? From here, we want to know what his probability is of getting heads again. So using that experiment, we could create a hypothesis of Kyle would, once again, get heads in 7 out of 16 attempts. So we can continue to use our experimental probability in creating future experiments. All right, now, my last thing for you guys today is I'd like you to go ahead and create a summary. And the one answer I'd like you to give for me is this. What is the difference between theoretical and experimental probability? Which one do we use more frequently? Now I'd like you guys to take a moment and answer this question. If you need to go ahead and pause this video, please go ahead and do that. All right. Now, I'm hoping that you've actually taken the time and gone through and created that summary. Let's get this started. So, in your assignment today, it looks like this. It is Math 7, Lesson 13, our topic, probability. Please make sure that you write both your first and last name on each one of these pages. There are 2 pages in this assignment. Today's date is the 12th, so that is my date of recording. This is for class period 2. So I'm going to do that on both pages at this time. I'm still getting a lot of work turned in without a name. I can't give credit where credit's due without a name, so please make sure that at least you put your name on here. All right? So let's begin. Questions numbers 1 through 6, we're using the directions atop in bold. It says, find each probability of one roll of a regular number cube, aka a dice. What is the fraction in simplest form? So, taking a look at this. Number 1, what is the probability of getting a 2 on a dice? Well, here I have one option, which is a 2. Because there's only 1 2 on a dice, and there are 6 total options on a dice. So my probability is going to be 1 over 6. Whereas for number 2, it says, what is the probability of getting a 3, a 4, or a 5? Well, I have 1, 2, 3 favorable outcomes, And on a dice, there's 6 sides. So 6 numbers, so 6 possible. So 3 favorable outcomes out of 6 possible outcomes. I'm going to need to reduce this. And I reduce this to be 1/2. So my probability of getting a 3, a 4, or a 5 is going to be 1/2. Number 3, what is the probability of an 8? Is 8 even on a number cube or a dice? It's not. So because there's no favorable outcome of an 8 out of possible outcomes, I will accept one of 2 answers. I can have 0 out of 6, or I will simply accept 0. Either one of those would be acceptable. All right. If you have any additional questions, please let me know for numbers 4, 5, and 6. All right, moving on to our next section. It says, a student is chosen at random from a 7th grade math class of 16 girls and 8 boys. Find the probability. All right. Now, here, we've got 16 girls and 8 boys in the class. That means that there are 24 total students. So if I want to know what's the probability that I'm going to, say, choose a girl out of the class, there are 16 girls out of 24 students. So I'm going to write 16 out of 24. And in this case, I'm going to reduce. So I'd get here both 8 goes into both 16 and 24. And when I do that, I get 2/3. Okay. All right. Next, number 8 says probability of a boy. So let's say I've got a boy in the class. Okay. There are 8 boys in that class out of 24 total students. Now I'm going to have to reduce. So that means that there's a probability of 1 out of every 3 students in the class is male. All right, I'm going to let you take on the rest of the problems. Number 13 says, color the spinner to match the given probabilities. One thing that we always need to have is a common denominator. So I would suggest for blue, green, and red that you find a common denominator with yellow. And I'm going to give you a hint. That common denominator is 12. So we would need to multiply this by 3 and this by 3. So that means that we actually have 3 out of 12 blues. 3 out of 12 slices on our color wheel are blues. And just do the best that you can with the colors. If you don't have all 4 colors at home, make up your own. Just make sure that the proportions of them are correct. Okay. 6 can go into 12 2 times. So I'm going to times the bottom by 2, top by 2. So that means that actually 2 out of 12 pieces are green. And 2 out of 12 pieces are red. Okay. Altogether, these should always add up to be your denominator. So make sure you pay attention to that as well if you got some funky numbers. All right. Now lastly, we've got questions 14 and 15. So these two deal with both experimental and theoretical probability. So pay attention to those notes. And if you have any questions at all, please send me a message, leave me a comment. I am here to help any way I can. Thank you so very much for watching. This has been Mrs. Ross Does Math.